Hi, here we're going to talk about probabilities involving AND with independent events. So two events are independent if the occurrence of one event does not affect the probability of the other. Here's a simple situation. If you flip a coin, you get tails, and then flip it again and get tails again. Was the probability of the second outcome somehow affected by the fact that you got tails the first time? No. So these two events are independent. And to find the probability of two independent events occurring, we use this formula, so we simply multiply the probability of each event. So if you roll a die twice, what's the probability you're going to roll 4 two times in a row? So the probability of 4 and 4, since these are independent events, is going to be the probability of getting a 4 times the probability of getting a 4. So each one of them is going to be 1/6, as I hope you know by now. And the answer is going to be 1/36. One card is randomly selected from a standard deck, and you replace it, and then you reshuffle the deck, and you pull another card out. And what's the probability? The first one is a 5, the second one is a face card. By the way, I'm just going to give you a heads up, the fact that we replace the card is important. So the probability that you have a 5 and a face card is going to be the probability of getting a 5 times the probability of getting a face card. So probability of getting a 5, we have 4 5s in the deck, so it's actually going to be 4/52 or 1/13. Probability of getting a face card, there are 12 face cards in the deck, which is going to be 12/52, which is 3/13, and it's going to be 3/169. Here's a spinner. You're going to spin it twice. What's the probability you're going to get a 10 the first time and an even number the second time? So the probability of 10 times the probability of an even number. The probability of getting a 10 is 1/10. Probability of getting an even number, you have half of them are even numbers, it's 5/10, which is 1/2. And the probability that this is going to happen is 1/20. Can you extend that rule to more than 2 events? Absolutely. You spin it 3 times, what's the probability you're going to get an odd number each time? So it's going to be the probability of odd times the probability of odd times the probability of odd, which is going to be 1/2 times 1/2 times 1/2, right? If you do the math here, you will see that it's going to be 1/8. Okay. Alright, the bag contains 3 red marbles, 5 blue marbles, and 4 green marbles. You reach into the bag, pull one marble out, replace it, put another one out, pull another one out. What's the probability that they're both red? So it's going to be the probability it's red the first time times the probability it's red the second time. We replace it. Red, you have 3 out of 12, so 3 12s times 3 12s, which is actually 1/4 times 1/4, which is going to be 1/16. The probability that the first one is blue and the second one is green, the probability we get blue times the probability we get green. So probability of blue, we have 5/12. Probability that the second one is green is going to be 4/12. I can simplify it just to make things easier towards the end. This is 1/3, so it's going to be 5/36, right? Alright, you have to be careful with problems like this. Neither one is blue. So the first one was not blue and the second one was not blue. The easiest way to do this, think about this. We have 5 blue ones, so we have 7 that are not blue. So probability not blue times the probability of not blue is going to be 7 12s times 7 12s, which is going to be 49 over 144. Alright. Remember, to calculate probability of not blue, you do 1 minus the probability that it's blue. That's another way to do that. Just let me remind you that in case if you forgot, it's going to be 1 minus the probability that it's blue. So it's going to be 1 minus 5 12s, which is 7 12s. This is just a side note. Our work for this problem is actually here. Okay? Moving on. The probability that Team A wins a game is 3/5. It's only a win-lose situation here. So what's the probability that the team's going to win 4 games in a row? Okay, so it's going to be the probability of a win times the probability of a win, right? Times the probability of a win times the probability of a win. So what happens here is going to be 3/5. Essentially you do 3/5 times 3/5 4 times, it's 3/5 to the 4th power, which is going to be 81 over 625. Find the probability that the team loses 4 games in a row. So if the win is 3/5, then the loss is going to be 2/5. Right? 1 minus the win probability. So it's going to be the probability of a loss times the probability of a loss times the probability of a loss times the probability of a loss. So it's 2/5 to the 4th power, which is going to be 16 over 625. But you sometimes see problems that ask, what's the probability that the team wins at least 1 in 4 games? So to calculate this, what we do is the following. We're going to say the probability that they win at least once is going to be 1 minus the probability of no win. Okay? Because if you subtract the probability of not winning a single game, you're going to get the probability that at least 1 game was lost. And that's actually here that it can be written as 1 minus the probability of a loss. Correct? And then we do 1 minus, we already have these numbers, 16 over 625, which is going to be 625 over 625 minus 16 over 625, and you're going to get 609 over 625. Okay, that's the probability they are going to win at least 1 game. Okay, and that's it.